class, this is Sir Alex. Welcome to Physics 1 and this is our first lesson in Physics 1 today. Today we'll be discussing about measurement units and conversion. The goal for this lesson are the following. First is for us to be able to solve measurement problems involving conversion of units, expression of measurements in scientific notation. What we mean by that is we'll be able to understand how we convert units, example meters to centimeters, and etc. At the same time, we'll be able to understand how to write longer numbers or longer quantities into simpler ones using scientific notation. We'll be also able to differentiate accuracy from precision and random errors from systematic errors. So let's discuss what is measurement and units. Measurement is basically a quantification of an attribute of an object. What does that mean is that an object has certain attributes, example length, weight, temperature, etc. When we put a quantity or a number on those attributes, that is called a measurement. So we are putting numbers on certain attributes like length, width, height, weight, temperature, etc. And then we use units in order for us to describe those quantities. Quantities in physics may be fundamental or derived. Fundamental quantities includes length, mass, time, temperature, so they stand alone. Derived units are the combination of fundamental quantities, such as speed. Speed is a combination of length, which is a fundamental quantities, and time, which is another fundamental quantity. So when we measured certain length over a period of time, that is speed, and speed is an example of derived quantities because it's a combination of two fundamental quantities. In physics, or basically when we're talking about measurement, there are two systems that we use in the world. One is the metric system, where there are two variations, MKS and CGS. MKS basically stands for meter, kilogram, seconds, and CGS is centimeter, grams, and seconds. And the second system of units that is used basically just in America is the English system, which we use foot, pounds, and seconds. In the Philippines, we most of the time we use the metric system, uh, but sometimes we also use the English system. When we talk about height, a lot of us ginagamit natin is feet. That is an English system. But when we're talking about weight, usually when you buy a rice, isang kilo, that is a metric system. The International System of Units, or the SI units, is the modern iteration of the metric system. It is the one that is used all over the world, whereas the standard that is being used all over the world. So if you are performing science experiments anywhere in the world, most scientists will use the SI units, which is the metric system. So whenever I talk about SI units or metric system at this point, know that we are talking about the standard international system of units. Here is the table of some of the fundamental quantities and units in SI units. So we use length, mass, time, temperature, electric current, luminous intensity, amount of substance, etc. These are just some of the examples. Length, we use the meter unit, and the symbol for that is m, kg for kilogram, s for seconds, k for Kelvin. So a lot of you may think that the SI quantity for temperature is Celsius, but it's actually Kelvin. But for all intents and purposes for this class, we'll be using temperature if we are going to use temperature in any of our lessons. But know that this is the fundamental quantities present in SI units. Now let's talk about scientific notation and prefixes. When we are doing problems in physics, a lot of times our answers are too small or too large. That means we are writing a lot of numbers to quantify that number or that quantity. What we do to shorten the way we write numbers is the use of scientific notations and prefixes. So the picture on the right is an example of scientific notation. So instead of writing 45,000, we basically move the decimal point. A lot of you guys are already familiar with this, but if you guys are not, please listen. So basically what you want to do is you want to move the decimal point. For 45,000, the decimal point is at the last area. So kind of like where the red dot is at the moment. So what we do is we move the decimal points from right to left, from right to left. So 1, 2, 3, 4. When you reach the first number, uh, that's where you stop. And what you do is add the decimal point in between those two numbers. So it's 4.5. And then what you want to do is multiply it by 10 and raise to how many times the decimal point moved. So in this case, we move it 4 times. 1, 2, 3, 4. So it's 4.5 times 10 raised to 4. Another way of writing scientific notation is by the use of negative powers. And this time, the movement of our decimal point, instead of from uh, right to left, or yeah, right to left, the movement of the decimal is from left to right. As you can see here, we have 0.00076. So if we move the decimal point 1, 2, 3, 4, as soon as you arrive at first whole number, that's where you add your decimal points. So you have 7.6, and then multiply it by 10 and raise it to basically how many times you have moved the decimal point. In this case, we move it again 4 times. 1, 2, 3, 4 from left to right. Again, positive, it means that the decimal point moved from right to left. And for negative, it means the original numbers decimal points move from left to right. So what if we have this number and we want to write it this way? So you basically have to move the decimal point from left to right and vice versa for this one. So you want to move this from left or from right to left. So next is prefixes. So here is a list of some of the prefixes we use in science. But for most of the time, we'll be focusing on kilo, centi, milli, micro, and nano, sometimes pico. So these 1, 2, 3, 4, 5, 6, 6 prefixes are the ones that you'll be seeing a lot of times in our lesson. So I want you guys to be familiarized with kilo. Kilo is basically we multiply things to 1,000. So for example, we have a base. Let's say we have 1 as our base. Let's say 1 meter. If we want to change meter to kilo, so that means 1,000. 1 times 1,000. So meaning 1,000 meter is equals to 1 kilo. Okay. Next is centimeter. So centimeter is a hundredth of the base. So for example, we have a base of 1. So 1 meter is basically 1 divided by 100, and that's 1 centimeter. So example right here, 1 meter is equals to 100 centimeter, because 1 centimeter is equals to 1 over 100 of the base. Millimeter is a thousandth of a base. A micrometer is a millionth of the base. And nanometer is basically a billionth of the base. So meaning 1 nanometer is equals to 1 over 1 billionth of the meter. So it means 1 meter is equals to 1 billion nanometer. And if we use the scientific notation to shorten numbers such as this is too long, to save time and to save spaces, what we do is we move the decimal point, and as soon as we arrive to the first digit, 1 times 10. Basically move the decimal points 9 times, so 1 times 10 raised to 9 nanometer is basically equal to 1 billionth nanometer. So kilo is a multiplier of 1,000, so K. So when you hear people say 1K, 2K, we know that's 1,000 because K is a thousandth and that's a kilo. K is a multiplier of 1,000. So 1 meter is equals to 0.001 kilometer, and that's 1 times 10 raised to negative 3 kilometers. So here's some examples. So 2500 of a meter to kilometer is 2.5 kilometers. 5 centimeters to meter is 0.05 meters. 9.5 nanometers to meters is 9.4 times 10 raised to negative 4 meters. So a lot of times in physics we have we'll be doing a lot of this conversion right here. So now let's talk about and how we can answer conversion like this. What we do is we create a what we call a conversion ratio. So in many physics problems, sometimes we need to convert SI units. We need to convert nanometers to meters and vice versa, etc. And in SI units is used because it's quite convenient to do these unit conversions because a lot of them are related by integral of 10. The simplest way to convert a given unit to another set of units is to use a conversion ratio, meaning equal to 1. The unit you want will always be in the numerator, so the unit that you're trying to find, the new unit that you're trying to find will be in the numerator, while the unit you want to replace will be in the denominator, and it's usually in units of 1. Then multiply this ratio to the original quantity. What do I mean by that? So let's try a sample problem. So nanotechnology is a term that it embraces the use of materials of sizes in the order of nanometer. What is 2 nanometers in 1 meter and in 1 meter and 2 centimeter? So let's try that. So we have our sample problem here. Okay. So let's just make sure. Okay. So nanotechnology is a term that embraces the use of the materials and the size and the order of nanometer. So we are changing 2.0 nanometers, and we want this 2.0 to change to first meter and then centimeter. So in order for us to do that, what we need is a conversion ratio. So conversion ratio, as I mentioned, also discussed earlier, we put the unit that we want on top and the unit that we want to replace on the denominator. And this is the technique that I use in order for me to easily answer these conversion units. So what I do is I first write the unit, the original unit, and what I do is I create a straight line. And after I created a straight line, I do this, and then I proceed with the conversion. So how do I know the conversion? So first I have to convert nanometers to meters. So what I do is I put the nanometer in the denominator, and it's usually in the units 1 nanometer, and what I want is meters, so I put the meter in the numerator. Okay, and now I have to find how many meters in 1 nanometer, and we know that there is 1 times 10 raised to negative 9 meters in 1 nanometer. And then what I do is I close this. So this is my multiplier now. What I do then is then we cancel the units and then basically multiply 2.0 to 1 times 10 raised to negative 9. So our answer would be 2.0. Basically, we just write 2 times 10 raised to negative 9 meters. So in 2 nanometers, there is 2.0 times 10 or 2 times 10 raised to negative 9 meters. So this is our first answer. So this is our answer for number 1. Next, we want to change. We want to look for 2 nanometers and in centimeters. What I do is I don't need to create a new one. What I just need to do is continue on kasi alam naman natin na itong meter nito is already equal to 2.0 nanometers. So we can just use this meter and continue converting it to centimeter. So what I'll do here is I want meter on the denominator, and again I want 1 meter so that we can cancel that meter. And then now what we want to find out is how many centimeter there is in a meter. And we know that there's 100 centimeters in 1 meter. So we then just gonna cancel the units and then multiply 2 times 10 raised to negative 9 to 100. And then the answer would be 2 or 2.0 times 10 raised to negative 7 centimeter. If you guys don't know how to do that, you can just use calculator. If I were you, I would use the calculator so I won't be wrong. So our answer would be 2.0 times 10 raised to negative 7 centimeters. So this is our answer for number 2. So that's how we convert 2 nanometers to meters and centimeters. How about let's try another one. So practice problem number 1. So the unit Armstrong symbolizes by this unit right here, Armstrong, A, is named after Andrews J. Armstrong. Given that 1 angstrom is equals to 0.1 nanometers, what is 1 angstrom in centimeters, meters, and millimeters? Okay, what I will do is first I'm going to write the original numbers or the original unit, which is 1 angstrom, and then I'm gonna draw my very long line. Okay, and then what I want at the bottom is the unit Armstrong and the units and 1 units, and we know that 1 angstrom is equals to 0.1 nanometers. Okay, and then we're just gonna close that. Okay, what we're gonna do is we're gonna cancel this and then multiply 1 times 0.1 nanometers. And then since we're not looking for nanometers, we're looking for centimeters. So let's write centimeter here and nanometer at the bottom. So we know that there's 1 times 10 raised to negative 7 centimeters in 1 nanometer. We can cancel the nanometers, multiply 0.1 to 1.1 times 10, 1 times 10 raised to negative 7 centimeters, and the answer would be 1.0 or 1 times 10 raised to negative 8 centimeters. Okay, so that is our first answer. There's 1 times 10 for letter A. Next, we're going to continue on. Okay, next we want centimeter at the bottom. So how many how many meters are there in centimeters? So now we're looking for centimeter or meter, and we know that in 1 centimeter there are 0.01 meters. We're gonna do this, we're gonna cancel centimeter and multiply 1 times 10 raised to negative 8 to 0.01, and that's 1 times 10 raised to negative 10 meters. So that is our answer for B. And then lastly, we're going to do, so we're going to convert this to, just have to move this a little bit. Okay, what we want at the bottom is meter. We're just going to elongate this one. Okay, and the unit that we're looking for is millimeter. So in 1 meter, how many millimeters? We know that there's 1,000 millimeters. Then we're going to cancel the meter, and the answer we're going to end up is multiply 1 times 10 raised to negative 10 to 1,000, and the answer would be 1 times 10 raised to negative 7 millimeter. So that is our answer for C. Okay, so now we'll be able to answer using conversion. So okay, so these portions right here, I'm gonna mark them. These portions right here and these ones are what we call the conversion ratio. Those are all the conversion ratio, and those are essential in convert in unit conversions. Okay. Oh, let's go back. Okay. So now, let's discuss accuracy versus precision. Accuracy refers to the closeness of the experimental values to the expected or true value. It's also the degree of veracity, while precision refers to the closeness of the experimental with one another. It's the degree of reproducibility. So when we talk about accuracy, it refers to how close yung nahanap natin na number dun sa totoong value na hinahanap natin. So example is on high accuracy is halimbawa yung bullseye nito, ito yung correct number. And if we take measurements and yung number natin is really close to that value, then we have a very good accuracy. Precision, on the other hand, refers to the closeness of the experimental with one another. So, kung accuracy is the comparison to the true number, yung precision is the comparison dun sa mga values na nakuha natin. Halimbawa, you take measurements of the length of a building 10 times. Dun sa 10 number mo, ilan dun sa number na yun is magkakalapit yung value. Because sometimes you can be accurate but not precise, and sometimes you can be precise but not accurate. So here's an example. Yung xi is yung true value and yung x's are the values that you get. So in this scenario, you have very high accuracy and high precision kasi malapit siya doon sa true value and yung mga values na kinuha mo is magkakalapit din. Here is an example of low accuracy but high precision. Ito yung value na hinahanap mo pero yung lahat ng sagot mo is nandito. And yung lahat ng mga measurement na kinuha mo is magkakalapit. It means you have very high precision pero yung mga numbers mo hindi naman yung true value. It means you have low accuracy. There is a situation that you are high in accuracy, malapit yung mga values mo dun sa true value or dun sa true answer, but sometimes you have low precision. Pero yung mga numbers mo is medyo magkakalayo. Malapit sila dun sa true answer pero magkakalayo yung mga nakukuha mong value dun sa if you compare them to one another. And sometimes you have low accuracy and low precision. Malayo yung number mo dun sa tamang sagot and malayo yung mga number na kinuha mo sa isa't isa. So in an experiment, you want both accuracy and precision. So a good experiment needs to be both precise and accurate. Lastly, random errors versus systematic errors. Random errors are errors in the measurement or reading due to the precision of the instrument. So random errors happens because of the instrument. So yung precision ng instrument is mali, but it can also be because of the experimenter's inability or inexperience to measure uniformly. So madalas yung experimenter o yung nagko-conduct ng experiment is hindi precise yung pagkuha niya or yung paggamit niya ng tool is hindi tama or paiba-iba. So minsan nagkakaroon ka ng random errors. The results in inconsistent data obtained can be R. So how do we solve for this? It can be mitigated by averaging a large sample of measurements. Kung yung mga nakukuha mong number dun sa measurement is hindi pare-parehas, what you want to do is get a lot of them and then make an average. Get the average of those numbers and then your answer may be close to the real answer. Systematic errors are the errors due to the equipment itself or due to the flawed experimental procedures. So this naman yung systematic errors is errors mostly because yung measured tools mo is imperfect. This happens and yung solution for this is to calibrate your equipment. And sometimes it's also due because of the experiment itself. So yung method of measuring mo and experimenting mo is may flaw or mali mismo dun sa experiment kaya yung nakukuha mo is hindi tama. There's an error. This can be resolved by the calibration of the equipment or revising the experimental procedures. So that's the difference between random errors and systematic errors. So that's our lesson for today. If you guys have any questions, feel free to message me anytime and have you guys have a good day.